With this series of videos, we are starting a brand new unit dealing with exponential expressions. In this unit, we are going to learn about what exponents are, at least in the primitive sense, and we're going to look at algebraic expressions that have exponents and learn the different rules we can use to simplify and manipulate them. And so without further delay, let's get into our definition of exponents. And basically what this slide says is if n is a natural number, then a to the power of n equals a times a times a times a, and there are n factors of a. In other words, if I had an expression like 3 to the power of 4, 4 happens to be a natural number, right? It's very important that it's a natural number. And natural numbers, by the way, are, another word for them is counting numbers, like 1, 2, 3, 4, so on and so forth, right? They're not fractions, they're whole numbers, but they start at 1, right? Nothing less than 1. These are what are called natural numbers. And so if your exponent is a natural number, you just say that, well, your base is 3, your exponent is 4, you're multiplying 4 threes by each other, right? You're multiplying 3 by 3 by 3 by 3, kind of in the same way that if you had multiplication 3 times 4, you could write it as the addition of 4 threes. Basically, 3 times 4 is just a repeated multiplication of 3. There are 4 threes that we are multiplying. Now, what is the importance of us saying that it is a natural number? Well, if the exponent is not a natural number, this definition doesn't make a whole lot of sense. For example, 3 to the power of 0. Well, what exactly does that mean, right? Or 3 to the power of 1/2, or 3 to the power of -2, right? When this exponent is not a natural number, when it's a negative, a 0, a fraction, we haven't even gotten to some of the more exotic things that you would learn in higher level math courses if you chose to take them. Exponents don't quite behave like this. There are a few more rules, but for the purposes of this video, for now you can think of exponents as just that, as repeated multiplication. So let's take a look at a few examples. I guess before we do, just a quick reminder, when we deal with an exponential expression, we call the bottom number the base and the top number the exponent, or sometimes it's called the power. And when you read an exponential expression like this, this is read as a to the power of n, or a to the nth power. This is not properly said an. You have to say it a to the power of n, or a to the nth power. So looking at our first example, we have 2 times 2 times 2 times 2. How would we write this in exponential form? Well, the number that we keep repeatedly multiplying by itself is 2, so that's our base. We have 1, 2, 3, 4 of these 2s, so the power is 4. So 2 to the power of 4. Let's take a look at the next example. -6 times -6. Again, our base is -6 because that's the number that we keep multiplying by itself. and there are 2 of them, so our power is 2. Now, here you have to be careful, because if you write your expression as I did, minus sine 6 and a 2, the order of operation says what's actually being raised to the second power is the 6, right? The minus sign gets attached later. If you want the whole number -6 to be raised to the second power, which of course is what you want, right? Because you're multiplying -6 by -6, you need to put -6 in parentheses. So this is the correct way of writing -6 times -6 in exponential form. Let's take a look at the next example. The number that's being multiplied by itself repeatedly is 8x. So that's our base. The amount of these is 3, right? There are 3 of these that are multiplied, so we raise to the third power. And again, if we do not put 8x in parentheses, if you read this expression, this says 8 times x to the third, right? I'm going to write it out in detail, right? And because multiplication comes after exponents in the order of operations, 8 is not involved in the exponentiation, right? You multiply x by itself and then you use the 8. You need to put 8x in parentheses to make sure that the whole quantity 8x is raised to the third power. Example 4. So we have 15 times a. There are 1, 2, 3, 4, 5 of them to the 5th. Notice here you do not want to use parentheses, because the only thing that's raised to the 5th power is the a. Only a is being multiplied 5 times. So if you put 15 in parentheses with the a, you would actually have the wrong answer, because the 15 would also be raised to the 5th power. So this is a bit of an introduction. You now understand how to go between repeated multiplication and exponential notation. And in the next video, we're going to start talking about simplifying variable expressions with exponents.